here. This is what I talk about, like why it takes time to do the design to get a real chip. To program the what? The custom design. Yes, you can. You can. PLD. Yes. Yes. Not the other one, because the first type is everything is fixed. You get it as the way it is from the market, and in order to get it to do what you want, your own function, you have to combine many chips, some of them together, right, in a certain way, connect them in a certain way to get the function as you like. Okay. So very soon, in a couple weeks, you will see the structure of VHDL, the program. Okay, to see how it can describe behavior of a circuit. Okay, if you like a circuit to perform a certain function, how to write VHDL program to do that. Okay, so here is the development process. Okay, for a chip, a digital chip. Here, that first of all you have to know what you want first, right? Understand the product requirement, design specifications. After that, you can start the initial design, right? After that, then you can do some tests to check if it is working correctly. Otherwise, you have to do the redesign. Okay. Once the design is correct, no bugs there, then it is okay to do a real implementation. Prototype implementation. Okay. This means you have to send it to a factory. Okay. After you get it back, then you can do the testing to make sure that there is no errors, okay, from the manufacturing or some errors that you overlooked before. Okay. Check if your design meets specifications. If not, see if that's the minor or the major errors. If it is a major errors, then you may have to redesign the whole thing from the software point of view. Okay. If it is the minor error, sometimes it could be fixed, okay, from the manufacturing. So you can see that there are many loops here. Okay. Design, redesign, testing before you can get a final product. Okay. Questions? I guess everyone read the chapter. Yes. Mm-hmm. In this class? In general? Yes, yes. Yes, yes. Mm-hmm. But in this course, we are going to focus on the theory and design using software. We are not going to work on a real chip. Okay, that part you are going to have it in a lab next year. Unfortunately, we cannot move it to next semester. Okay, but from the software simulation, you can get a lot of insight information. Okay, to compare the practical perspective and the theory, if they are the same or difference, how much difference, and why, things like that. Okay, to make sure that you understand the theory, you have to know how to implement in the software doing the simulation. Okay, we are going to have it in this class. It's gonna be a lot of fun, actually. Requiring that you have to spend quite some time learning how to use the software. Okay, get together with friends and then play with the software together. Okay, yeah, that's gonna be much more fun than just the theory, right? Mm-hmm. Okay, all right. I'm gonna skip some part of it and then jump to pretty much a conclusion for this chapter. That just like what we just said, the theory and practice, both of them are important. They have to go together. Okay, there must be some balancing between the two. The theory, okay, in order to be a good designer, you have to understand the main concept, how to do a good design circuits, right? And test the circuit using the software. You may find out that many times you don't have to understand the theory. You can use a software to draw something, to create a circuit as you want. Okay, you can get a circuit, but you won't get an effective circuit, meaning that with very high speed or with a minimum size, okay, if you don't know how to do a good design, you don't know how to synthesize or optimize the circuit. Okay, so that's the main difference. Okay, how to do an effective design. Okay.